Let's solve the following problem. Give an equation for the sphere with center at the point with coordinates -2, 1 and -1, and passing through the point Q with coordinates 1, 0 and -3. So in order for us to have an equation for the sphere, we'll need its center, well, that we already have, and we also need its radius. Well, if it has a center P and it passes through the point Q, Q is on the surface of the sphere, then the line segment connecting P to Q should have the length of the radius. So the radius of the sphere is the length of this vector from P to Q. What is this vector? Well, we just have to take the difference of coordinates. So 1 minus -2, that's +3, 0 minus 1, that's -1, -3 minus -1, that's -2. And what is the length of this vector? Well, it's the square root of the squared sum of its coordinates. Which is simply 9 plus 1 plus 4, that is 14. So the radius of our sphere is equal to 14, root 14, that is. Now the equation of the sphere then can be written as x minus the first coordinate of the center, which is -2, so x minus -2, that's x plus 2 squared, plus y minus the second coordinate of the center, that's 1, so y minus 1 squared, plus z minus the third coordinate of the center, which is -1, so z plus 1 is what we have to square, equals the radius squared, and that is 14. So let me just write that this is the radius squared. So the equation of the sphere is x plus 2 squared plus y minus 1 squared plus z plus 1 squared equals 14. Now let's find x, a real number, such that the vector u with coordinates -1, -4 and x is perpendicular to the line given by this point 4, 5 and 7, its coordinates, plus s times this vector 2, 1 and -3 are its coordinates. So what we have to do is to separate, look at this line and take out this vector w, because this is the vector that is giving us the direction of the line, and what we need is this direction to be perpendicular to our vector. So in order to have u being perpendicular to v, the direction of the line, we need their scalar product be 0. What is the scalar product of these two vectors? -1, -4 and x, and 2, 1, -3. Well, let's see. Multiplying the first coordinates gives us -2. Multiplying the second coordinates gives us -4. Multiplying the third coordinates gives us -3x. And this has to be 0. Well, let's rearrange this equation. We'll get that 3x has to be equal to 6. Dividing by 3 gives us x that is equal to 2. So the vector u has the coordinates -1, -4 and 2. And you can check that this vector is indeed giving you a 0 scalar product with V.